And then we are also working with, in the context of cardioimmunology, thanks to the collaboration with Professor Matteo Pasquali at the Rice University in Houston. And I mean, just to share the point that this approach can be applied in very different contexts where immune cells are still important. And then I would like to go into the conclusion of my talk and to share with you a part of the projects we have ongoing, which is related to space biology. So what we would like to do is to study the action of nanomaterials and the applications of nanomaterials in the context of space, to use them to counteract the possible health problems of astronauts. And this is one point, but before going to that, we have to remember ourselves. What is the big difference? So the big difference is the microgravity environment. So all the problems we can have in using nanomaterials on Earth can be even more problematic if we think about the microgravity. And this is because if we think about the possibility to travel into space, probably we will have a bone loss, and also our immune system may suffer about the lack of gravity. And also another problem which is very common for astronauts is related to the wound healing. So those are the three problems which are all of them kind of related to also, of course, immune cells. And in this context, we would like also to think about the possibility to use microgravity as a biological model. For example, for diseases such as like osteoporosis, so very particular conditions. And in this context, we used, for example, carbon nanotubes a few years ago for the part relating more to the immune modulatory properties. Now we are working with eniotashotti in the context of bone loss, again using different kind of nanomaterials. And now we just started with a project related to wound healing. It is a project that was funded by the European Space Agency. And again, we are using different nanomaterials, in particular in my case, graphene, exploring its potential also in the context of space. And the coordinator is Professor Carlo Ioro in Brussels, and this is in collaboration, strong collaboration with Andrea Ferrari in Cambridge University. And with that, I'm really, I promise, I'm really going to the end of my talk. I just would like to share very briefly that we published recently a review, a perspective paper. I was very honored because I had the opportunity to write this work with very with scientists of a very high profile. And in this review, what we would like to share are the potential of, in general, nanomaterials to fight COVID-19. Actually, thinking more and more about what we wrote just a few months ago, I think we should take this as an opportunity also to think about possible challenges that we may face as humanity in the future. And for that, I'm also part of the Advanced Material Pandemic Task Force, which is a global initiative. And this is the link for maybe someone of you is interesting in join this network. Is really open, and we will be grateful for any new idea that may come from you. So what is the take-home message? The take-home message is basically that we can put in contact nanomaterials with immune cells. We can, in simple words, get an immune activation or an immune suppression, and we should think about the opportunities we may have with both types of actions of these nanomaterials. And with that, I would like to thank the projects that the funding agents that allow us to work on this field, in particular the Genomics and the CarbioMap project. And here is the people in my lab and my collaborators. So I would like to thank you all for your attention.
Just on a practical level, really curious to understand all of your in vivo testing that you do. You showed some cases in the mouse and then also in the pigs. And is it possible to move some of these to cell lines, human cell lines? And what are and consider some of this testing to be done in a more cost-effective, perhaps high throughput way, to also look at the effects on immune cells and so on?
Okay, good question. So, well, first of all, I have to admit that most of the time we work with human immune cells. So with pigs, I mean, we have been working with pigs mostly in vivo. So by intravenous injection or intraperitoneal injection, but my lab really focus only on human immune cells, and most of the time from healthy donors. From the mice, of course, I mean, the point is that are still, I don't know if to say unfortunately, but this is what we need to use if we want to test and to go more close to a translational level. So we did that for the graphene conjugated with the calcium phosphate. Of course, then the work was published on nanoscale, which is, I mean, is not the top, but is, I think, is still good. And yeah, of course, they were asking about the test, like in a more close to human model. So Federica, I don't know your opinion, but I really like the line where we test before on human cells ex vivo, which I think it's a really good model, like close to in vivo for immune cells, and then we go and move forward to animal models.
I was just wondering, you know, about your application of the carbon, the small carbon that you had there in the bone. Do you actually consider this carbon material biodegradable? And
okay.
just, I don't know, you know, it seems to always be very chemically resistant, correct?
Yes and no. I mean, yeah, graphene, there are a lot of studies where they prove that is biodegradable, and I think I'm not the best expert in this, but one of the best experts is Alberto Bianco and Ben Fadil. But I mean, yeah, graphene oxide is, I mean, it's proved that is biodegradable. Then, of course, if you talk about like what is the long-term consequence on that, I think there is a lot of going on, and it's too early to have like a sharp answer to that. So.
No, okay. And could this material...
I think also it's very related to the type of graphene. So.
No, okay.
It's I think we need more studies to that, to be honest.
Yeah.
But
and could this graphene material be used in any way for COVID-19 related purposes?
okay, yes.
The short answer would be yes.
How would you use it?
Can I answer to that?
Yes, please.
Okay, no, because there is some
there is something in the background. I'm not sure where it's coming from, but yes, please do answer.
Okay, yeah, sorry. So, okay, one of the most common application for graphene today is the use for personal protective equipments. So, I mean, there are already some of them in the market, like for masks. And this is one of them. Then I know that there are studies ongoing to use graphene also as a part of a solution to self-disinfecting surface. Again, like for hospitals or more, I mean, not in general, but like in public places. And this is something that is, I mean, I think I will say that one of the most common use is the graphene for masks, like to integrating it into masks. Then, as for other nanomaterial, we may think to use it like functionalizing it with antibodies and so on, but I think it will take more time.
Okay, we have a couple more questions. One is from the attendees. Any thoughts on the effect of graphene on coagulation or complement activation?
Oh, okay. I mean, yes, there are different studies showing the complement activation. Again, as I said, I think that if we look at the literature, even very early literature, there is sometimes a bit of, I will say confusion related to the fact that the type of characterization we can have today of the material is much better compared to what we could have like 3 or 4 years ago. So I think the field is going so fast that what we can see published just a few years ago maybe can change depending on the quality of the material and also depending on how deep can go the characterization of the material. So the answer can be yes, but we need to admit it really depends on the type of graphene we are talking about.
Thank you. And then I believe we have a question from Marcel Bauli. Perhaps he can directly ask the question if you like. Yep.
I will. Hi, Lucia. You do a lot of studies looking at interactions with immune cells, and I'm assuming those are done in the presence of serum proteins. And it makes me wonder, how do serum protein binding affect the graphene properties? And is it the graphene that's interacting, or is it the proteins that are bound to the graphene that are interacting with the immune cells?
Okay, thank you. Okay, so you are talking about the protein corona, I guess. So,
yeah.
So, yeah, I mean, yes, there are different studies coming from the group of Manchester, from Costas Costarelos, and they also performed some study using human samples. So, we know that graphene does have the problem of the protein corona formation. I mean, it can be a problem, it can be not. It depends on what type of application we may think about that. For my personal research, what we are going to do is to study the protein corona in pigs, which is actually what we are doing now. Yeah. But I think it's too early to share today, maybe next time. So I'm sorry.
No, that's all right. I was just wondering if you've ever tried using protein-free medias when you culture your immune cells to look at the interactions.
No, unfortunately, no. That's
Okay.
a good point. Yes, you're right.
All right. Thank you.
Thank you.